Hi guys, in this video we're going to do another example using Coulomb's law. This example is also in your packet. It's the second example. On the back side, this is page 18 in your packet. So now we have two charges. This is a two-charge example. This one's a little bit more difficult because we have to think about the net force on some things. So let's take a look at this. So it says that we've got two charges, Q1, which is 0.006, Q2, which is 0.002, and Q3, which is negative 0.015 coulombs. They're on a straight line. We're drawing the picture. And it tells us the distance right here. 3 meters and 4 meters are in between those guys. And it says we need to draw a picture of all the forces on Q2 and then calculate the total force felt by Q2. Okay, so what we do when we have two charges or more, or three charges or more, is we take a look at sets. So it's always a two-charge interaction. So first we can look at Q1 and Q2. So that's what this A says. Draw the force on Q2 due to Q1. So let's pretend this is Q2. Now Q1 is also positive, so those forces are going to be away from each other. So it's going to be pushing that way and pushing that way. So on Q2, Q1 is pushing it that way. I don't know exactly how much, but we can calculate that later. So that's just Q1 pushing on Q2. Now the other set of forces that I have to look at is Q2 and Q3. So Q3 is negative, positive and negative here, so this positive charge is going to be pulled toward the negative. So both of those forces are in the same direction, which kind of answers question C. What do I notice about the two forces? They are in the same direction. Now, what does that mean as far as finding the net force? Well, if you remember from Physics 1, when you find the net force, you add them up or subtract them. You add if they're in the same direction, and you subtract if they're in opposite directions. So these are in the same direction, so I will need to be adding these. Because forces are vectors, that means that they combine. Okay, so now let's calculate the force and then find the total. So it says calculate each force and then find the total. Now the one from Q1 I'm going to call F1, okay, just so I can keep them straight. And then I'll call the other one F3. Now it's the same formula, K, Q1, Q2 over R squared. And here I've got my 9 times 10 to the 9th. My Q1, it says, is 0.006, and my Q2 is 0.002. And my distance is 3 meters. Now don't forget to square that. Whoops, not third, square it, because that's necessary. So again on my calculator, 9 times 10 to the 9th times 0.006 times 0.002. That gives me 108,000, and I'm going to divide that by 3 squared, which is 9. So in my calculator, this box isn't big enough. In my calculator, I'm going to do that number divided by 9, and I get 12,000. That's a nice, easy number. 12,000 newtons from Q1. Now that is going to be in the direction of, that's to the right. So I'm going to write right on there. Okay, so now I got to find F from the Q3. So I'm going to write the equation down again. K, this time instead of 1 and 2, I have 3 and 2. And then a new distance. So 9 times 10 to the 9th still. This time my Q3 is negative 0.015. That negative is going to drop out here in a little bit, but that just means it's not going toward it. And then I've got 0.002, and then my distance now is 4 meters, and I have to remember to square that one also. Okay, so 9 times 10 to the 9th times negative 0.015 times 0.002, and I'm going to get negative 27 and 4 zeros. Okay, now that one I'm going to be dividing by 4 squared, which is 16, divided by 16, and 16875. Now I'm going to, instead of writing down negative, I'm going to write down the direction that this force is in, because the negative here tells me which way the force is going, and since I know it's going to the right, I can just look at the value itself. So I'm going to write right on there. Okay, Now, The total force is going to be the sum of those. So I'm going to take F1 and I'm going to add it to F3. So I'm going to take 12,000 newtons and I'm going to add it to 16,875 newtons. Let's see, 12,000 plus 16,875, and I get 28,875 newtons, and that's going to be to the right. So this arrow is my 1875. It should have been a little bit longer perhaps, and this one should be a little bit shorter because it's only 12,000, but at the time I didn't know. I didn't know how big those forces were, and I knew this was smaller, but it's got a smaller distance. Or is it bigger? Oh, it is bigger. And it's got a bigger distance, so I didn't really know which one was going to be bigger or smaller. So that's okay, but what I do when I have more than one charge is I add them up. Now it can get really tricky with some of those, but that's okay. That is an example of a 3-charge kind of question. So if you have any questions about these, make sure you ask your teacher. If you would like to see further examples, watch another video. Thanks for watching.